Hello! In one of my previous videos, someone asked me how to learn programming and what the best way to do it is. And I've been thinking about that question quite a bit. Obviously, programming courses are great. There are tons of them online, many of them free, and they are super useful. But right now, I don't feel like I have enough time or experience to create a proper course myself. However, one thing I am sure is that the best way to learn programming is simply to sit down and code. Like, take a project that you find interesting, try to recreate it, and then slowly start adding your own improvements or features to it. I started thinking about my own process. I started something somewhat related to programming, but even then, you don't learn every language. And in my case, at work, I mostly use C or C++. When I started uploading these videos, I decided to use Python because it's simpler. But even then, it wasn't completely new to me, since I had already used it for things like data or graphs. But then I realized that I had never really built any kind of graphical interface with Python that wasn't just the terminal. So I thought, okay, what better way to motivate people to learn something new than to actually learn something new myself while recording it? So this project is kind of a learning process for everyone, including me. So today I'm going to be building the game Pong in Python. And for this interface problem, the solution I found is the library called Turtle, which is honestly one of the easiest ways to create simple graphical programs in Python. It basically gives you all the tools to create a window, define its size, set colors, etc., etc. If you're really interested in this, I will leave the documentation in the description, because there's a lot of stuff you can do with it. Okay, after all the talking, let's actually start coding. So first we create the window using Turtle and define things like the size, the background color, and the title. Then we move on to create the actual object in the game, the two paddles and the ball. And this is the moment where I remembered why I don't usually enjoy working with graphical interfaces, because everything is based on pixels, and that depends on your screen, so you constantly have to test things visually. Personally, I prefer writing a lot of code first, running it once, breaking everything, and then fixing all the errors at once, instead of this more step-by-step process. But I guess if this is your first time programming something, this is going to be the best way to learn how to decode things. Here, I was trying to show that Turtle comes with some integrated shapes. For example, a square. It automatically draws a 20 pixels by 20 pixels square. But also, the fun thing is that you can resize it and change the width and the height. And that's all I did for this project. Some squares, changing its sizes and changing its positions. You might notice I am typing everything manually. Yes, I could just copy and paste. I do that all the time in my real projects. But for this video, I prefer the ASMR of me typing things, so I prefer to write everything. At this point, we already have the object created, so now we need to make them move. For that, we use key binding, so when the player presses certain keys, the paddles move up or down. Here I made a small mistake, which is pretty typical in Python. Since Python doesn't force you to define types or function signatures, functions that receive input behave a bit differently when you call them. And that's why we needed to use a lambda function here. Okay, now we have this infinity loop. This loop is constantly running, refreshing the screen and updating the position of all the objects. Since computers are very fast, this happens so quickly that it looks like smooth movement. Now we get into collisions, which is actually one of the most important parts of this game. The ball moves using two variables that we defined ourselves, the x and the y, which represents how much the ball moves in each direction every time the screen updates. So what we need to do is check if the ball goes beyond the limits of the screen. If it hits the top or bottom, it should bounce. If it goes past the left or the right edge, that means someone scored. The exact number we use comes from the window size. In my case, the width is 800 pixels, so the center is 0. The right edge is 400 and the left edge is minus 400. But we don't use exactly 400, we use something like 390, because the ball has size, and we want it to bounce when it visually touches the wall, not when its center reaches it. Coordinates in Turtle always start at the center, 0, 0, with positive value going up and up to the right, and negative values going down and to the left. And every position is defined using the X and Y value. We apply the same logic for collisions with the paddles. And when a collision happens, we simply multiply the X by -1, which reverses the horizontal direction of the ball, or the Y by -1, which reverses the vertical direction of the ball. If it goes past the paddle, it counts as a goal. Okay, this part is a little bit weird to explain. Let me try. You could see a visual bug where the ball went behind the paddle, but the code thought it was an okay position and bounced it like if it was bouncing with the paddle. And I did some takes, I did some tries, and the only solution I could think about is changing this error margin where I put only 10 pixels to a little bit more. Also, a small piece of advice if you're starting with programming. You don't need to know everything. Libraries already have tons of built-in functions, and it's completely normal to just look up how they work, or even ask for the AI for help. That doesn't mean AI can do everything for you though, because if you don't understand the code at all, and you ask for something huge like a full Mario game or something like that, it's not going to work, and even worse, you won't be able to debug it. And debugging is honestly a huge part of programming. Someone said that if debugging is fixing errors in your code, coding is making them. Next, we handle scoring. We store the score in variables and then display it on the screen using something called a pen, which is just a turtle object used to write text. The only slightly annoying thing is that to update the score, you basically have to rewrite it completely every time. That means deleting the old pen, erasing it actually, and writing a new score. Okay, at this point, the basic version of the game is done, but it felt a bit too simple, so I decided to add a few more improvements. First, I added multiple rounds, so the game doesn't end after a single point. We asked the player how many rounds they want to play, and yes, I even added some basic validation, even though I'm probably the only one playing this. To track the game state, I use a global variable, which is basically keeps its value between function calls. That's very useful here because we need to keep track of the score across the entire game. I also added a winner message at the end using another pen, just placed somewhere else on the screen a little bit bigger. At this point, I also clean up some parts of the code. Repeating code is usually a bad idea, so if you find yourself copying and pasting logic, it's a good sign that you should turn it into a function. And finally, I added a small gameplay improvement. At first, playing alone was kind of boring, so I made it so that every time the ball hits a paddle, it speeds up slightly. Instead of just multiplying by -1, we multiply by something like -1.05, so the speed gradually increases. This creates another problem though. When a round resets, we don't just reset the position, we also need to reset the speed. And since the speed is tied to direction, we randomize the direction again at the start of each round, so the ball doesn't always move the same way. At first I only increased the speed in the X direction, but that felt weird when the ball moved diagonally, so I applied the same logic to both X and Y. And yeah, that's pretty much it. That's how I build Pong in Python. I hope you enjoyed it, and if you have ideas for other projects I could try, feel free to leave them in the comments. Thanks for watching, and I'll see you in the next one.